Hello, y'all. This is the Factoring Methods Organizer. This is going to be a review of every method of factoring that we have learned at 5.5, 5.6, I gotta go to the next page, 5.7, 8, and 9. So we have learned how to factor so many different ways that we want to make sure that you guys can see it all in one way, compare when you use them, and compare how they are similar, how they're different, things like that. So at the top here, what we're going to do is I'm going to do the problem on the left, and then have whoever is playing the video, your substitute, Miss Ishman, your para, your math aide, have whoever's playing the video, or yourself if you're watching this later, pause the video and work on the problem on the right. Give everybody some time to work on that, and then we will continue on the next example. So we'll do one together and then work on one on your own. So the first thing I have up here is some review of what we are doing when we are factoring. When we are factoring, we divide our coefficients and subtract our exponents. When we are multiplying things out, we are going to multiply our coefficients and add our exponents. So knowing the difference there and knowing that multiplying and factoring are the opposite of each other is really important. And we are actually going to do every example after we factor it. We're going to multiply it back out to check our answers. And then the last thing I have here is once we are checking our answers and we want to combine like terms, when we do that, we want to add our coefficients and we want to leave our exponents alone. We don't change our exponents at all there. So the first method of factoring we learned was greatest common factor. We use this if there's a common factor between all of the terms. It doesn't matter how many terms you have, it just matters if there's a number that you can divide out of all of them, and or if there's x's that you can factor out of all of them. So this first one, we're going to put an imaginary 1 here on our 8x to the first, and then we can divide all of these terms by 4, and then we can also pull out an x to the first. You're always going to be able to pull out however many x's this last guy has. Now we are going to divide all of our coefficients. So 12 divided by 4 is 3. We subtract our exponents. 4 minus 1 is 3. And then we keep going with that. We divide our coefficients. Negative 16 divided by 4 is negative 4. And we subtract our exponents. 3 minus 1 is 2. And then 8 divided by 4 is 2. And we subtract our exponents. X to the first 1 minus 1 is none. We factor that x to the first out all the way. I'm going to scoot that parentheses over. So that is our fully factored form. And then the second thing we're going to do on each of these examples is we're going to multiply these out. So to check this, we would multiply this out. We would do 4 times 3 to get 12. Add our exponents. X to the first times x to the third. We would add 1 plus 3 to get 4. Then 4 times negative 4 is negative 16. Add our exponents. 1 plus 2 is 3. And 4 divided times 2 is 8. And then we can distribute our x to the first out. And if you look, what we have right here is the exact same thing we have right here. So go ahead and pause this video now and work on the next example. Work on factoring it and then multiplying it back out to check your answer. Okay. We are back for 5.6. So 5.6 is factoring quadratics part 1. We used this when there were 3 terms with no number in front of x. So if you look right here on our x squared, there's an imaginary 1 there. We can add that in. I'm going to take it away. But there's an imaginary 1 there. There's not a number, not a coefficient other than 1 there. When we are doing factoring quadratics like this, we have to find 2 numbers that multiply to the last number and add to the middle number. You guys also have a chart in your notes that we filled out together that tells you what number should be positive or negative. If you need to look back at that, and I think we put that on your note card as well, that you'll be able to use on your test. You'll do your review for that next class. So this one, we're trying to multiply to the last number, so we're trying to multiply to negative 20. And then we are trying to add to our middle number. There's an imaginary negative 1 there, so we're trying to add to negative 1. So the first thing I'm going to do is list all of my multiples of 20. My multiples of 20 are 1 and 20, 2 and 10, 3 doesn't work, and then 4 and 5. From there, I need to multiply to a negative, so I can either use my table to do this, or I can think about the only way to multiply to a negative is 1 positive and 1 negative number. So to multiply to a negative, one of these numbers has to be negative. I also know I need to add together to be a negative, so I'm going to make the bigger ones negative, make the more powerful ones negative. Now that I've done that, I can pick the pair that adds to -1, and that would be 4 and -5. So my answer here is going to be x plus 4 times x minus 5. Okay, if I wanted to multiply this out to check my work, I could. I would put x and 4 over here on the left of my box, x and -5 on top of my box, and then multiply those things out. X times x is x squared. X times -5 is -5x. 4 times x in the bottom left-hand corner. And then the bottom right-hand corner is going to be 4 times -5, which is -20. To write my final answer, I'm going to combine like terms and put it in standard form. So x squared goes first. Then we combine like terms, this 4x and this -5x combined together, -1x. And I still have my -20. And looky there, the answer I got is the same as what I started with. That's the goal, is to be able to factor it, and then undo my factoring to multiply to get back to my original answer. Okay, go ahead and pause this video, work on that x squared plus 12x plus 20, and I will see you back here in a moment. Okay, moving on to 5.7. Excuse me. 5.7 is difference of squares. Difference of squares tells us that if we have two perfect squares and we are subtracting them, then our factored form is going to be one plus the other, one of those perfect squares plus the other, and then that same perfect square minus the other. So on our first example, we've got 9x squared minus 49. 9 and x squared are both perfect squares. 49 is a perfect square, and then we are subtracting them. It's a minus in between. So 9x squared is 3x times 3x, so if you want to write that down. And then 49 is 7 times 7. So my factored form here is going to be 3x plus 7 times 3x minus 7. Okay, if I wanted to multiply that back out, I would put my 3x and my 7 on the left here, my 3x and my -7 on the top here. 3x times 3x is 9x squared. Got imaginary ones there we could have added. 1 plus 1 is 2. Top right-hand corner, 3 times -7x is -21x. Bottom left-hand, 7 times 3x is positive 21x. And then bottom right-hand, 7 times -7 is -49. Combining those together, this 21x and this -21x going to cancel each other out. So we've got 9x squared, and we got a -49. Awesome. Go ahead and pause this video, work on the next one real quick. I'll see you back here for grouping. Okay, factoring by grouping. Factoring by grouping works when we have 4 terms. There is not a common factor between all 4 terms. There is a common factor between the first 2 and the last 2. So, when we factor by grouping, we split into our 2 groups. So I'm going to look at my first group and my second group. Out of my first group here, 2 and 6, I can divide those both by 2. And then x cubed and x squared, I can pull out an x squared out of both those. So 2x squared is going to be my GCF for my first 2. 2x cubed divided by that 2x squared. The 2 divided by 2 is just 1. And then x cubed, pull out the x squared. I subtract my exponents when I'm factoring out. 3 minus 2 is 1, so it's just x to the first. So I could put 1x to the first, but that's the same thing as 1, or same thing as x. And then 6x squared divided by 2x squared. 6 divided by 2 is 3. And then the x squared divides out completely. 2 minus 2 is none. I have no x's left. Out of -3x and -9, I can divide both those by -3. If we remember, anytime that third term right there is negative, what I'm drawing an arrow at, if that is a minus, our second GCF is going to be negative. So I'm going to pull out a -3. -3x divided by -3 just leaves behind the x. -9 divided by -3 just leaves behind the +3. Okay, then the magic of factoring by grouping is that this and this now match each other. So x plus 3 is the first part of my final answer. The second part of my final answer is this GCF and this GCF added or subtracted together. So 2x squared minus 3. Okay. Multiplying that back out to check my work, I've got x and 3, and then I've got 2x squared and negative 3. Top left-hand corner, 2x squared times x to the first is going to be 2x, add my exponents, to the third. Top right-hand corner, negative 3 times x, negative 3x. Bottom left-hand corner, 3 times 2x squared is 6x squared. And 3 times negative 3 is negative 9. Okay, from here, my final answer I would put in standard form, so highest lowest exponent. So I would have 2x cubed. I would have that 6x squared as my next exponent, minus 3x, minus 9, and looky there, that is the exact same thing as what we started with. Okay, go ahead and pause this video, work on your 1 factoring by grouping 1 on your own, and then we'll meet you back here for 6.9, 5.9. Okay, last but definitely not least, and definitely not the least amount of work, we've got 5.9, which is factoring quadratics part 2. We have 3 terms here with a number in front of x squared. We need to find 2 numbers that multiply together to be a times c and add together to be b. So that's really similar to what we did in 5.6. Then we use those 2 middle numbers to split this middle term. Then we factor by grouping just like we did in 5.8. So this is like combining 5.6 and 5.8 together. So the first thing that we're going to do, I'm going to label our a, b, and c. Our a value here is 12. Our b value is negative 4. And our c value is negative 5. So a times c is 12 times negative 5, which is negative 60. So that's what we're trying to multiply to be. So we are trying to multiply to negative 60, and then we are trying to add to our b value. So we are trying to add together to be negative 4. So I'm going to start listing my multiples of 60, and then I'll worry about the negative in a second. So multiples of 60 are 1 and 60, 2 and 30, 3 and 20. Zoom out a little bit here. 4 and 15, there are so many, and 5 and 12, and 6 and 10. That's a lot of multiples. 7 doesn't work, 8 doesn't work, 9 doesn't work. And then 10's already on our list. If we want to add together to be a negative, we want to make we need to multiply to be a negative as well. We need to make one number negative, we want the bigger ones to be negative. So I'm going to make all of the bigger ones negative, this whole side. And the ones that add together to be negative 4 are this 6 and negative 10. So what I'm going to do now is I'm going to take this original problem. I'm going to rewrite it down here so you guys can see it on the screen, because I'm going to zoom in a second. 12x squared, minus 4x minus 5. And now we are going to split our middle term using that 6 and negative 10. So that's going to be 12x squared plus 6x minus 10x minus 5. And the reason why we're allowed to do that is I'm like uncombining like terms. That's 6x minus 10x there. We could uncombine those to be that negative 4x. From here we can factor by grouping. So out of my first 2 terms, I can pull out a 6 and an x. 12x squared divided by 6x is 2x. 6x divided by 6x, or anything divided by itself, is just 1. And then negative 10x minus 5. From those, since my third term's negative, I'm going to pull out a negative. And then 10x and 5 I can divide by 5. So, negative 10x divided by negative 5 is 2x. Negative 5 divided by negative 5 is plus 1. And then from here, my final answer is my parentheses that match, 2x plus 1 and 6x minus 5. Okay, one last step. Multiplying those both out to check our work, and you guys will be able to work on your last one and go back and finish up anything else you need to finish up. 2x plus 1, 6x minus 5. 2x times 6x is 12. 12. X times x is x squared. Top right hand, 2x times negative 5x, or negative 5 is negative 10x. Bottom left hand, 1 times 6x is 6x. Bottom right hand, 1 times negative 5 is negative 5. Combining like terms, this 6x and negative 10x can combine together, so I'll still have my 12x squared. Those guys combine together, 6 minus 10 is negative 4x. And then I still have my minus 5. If we zoom way out, we'll see that that was the original problem we had all the way up there at the top, 12x squared minus 4x minus 5. So you guys can work on your other 5.9 example and then finish up anything that you have left. See you.